An edge or an end? 13.8 billion years ago, there was a mighty explosion. Every speck of the universe's energy jammed into a very tiny point, and the forceful big blast from this extremely dense point created matter in the billions of galaxies that are mysteriously infinite universe. Infinite? Well, this is where the big questions arise. If you were able to get to the edge of the universe, what would happen if you exceeded the outer boundaries? Is there an end to the universe? In this video, we will reveal the truth about the edge of the universe. So stay tuned to the end as we embark on an amazing adventure. In 2009, the European Space Agency launched a space observatory called Planck to study the properties of the universe as a whole for what should mark the totality of the edge of the universe. But only its components were confirmed: the dark energy, the dark matter, free hydrogen, and helium, stars, neutrinos, and heavy elements. It lacked success in its main task to measure the afterglow of the explosive Big Bang that originated the universe 13.8 billion years ago. To answer recurring questions of what is beyond the universe, let's take an in-depth look at the universe and its components, its size, and its extension. The universe would definitely not have an external part if it were only defined as all the elements that could possibly exist in all of space and time. You might also want to imagine the universe having an exact size and imagining something outside that volume. In that case, whatever is outside has to be included in the universe. Although there appears to be an outer part to our observable patch of the universe, the current width of the observable universe is about 90 billion light years, and presumably beyond that boundary, there are a slew of other random stars and galaxies that don't appear to mark the edge. The observable universe is bounded by a cosmic horizon, much like the horizon at sea. Just as we know there's more ocean over the horizon, we know that there are more galaxies, possibly an infinite number, beyond the cosmic horizon. Their light simply hasn't had time to reach us yet. This tells us that our universe could be either finite or infinite in extent, as we only know its physical size must be greater than the portion we can observe. The evidence as to whether our universe encompasses all that exists, or whether it's only one of many universes making up a multiverse, is not concrete. Now, I know you want to jump to conclusions already with the answers to the questions asked earlier, but you might want to grab a glass of water and continue as we unravel this mystery. Nevertheless, we could resolve that the universe has an edge, not in space, but in time. Now you ask how. The Big Bang occurred at a known finite time in the past, 13.8 billion years ago, though with an uncertainty of less than 1%. This is because there's an edge to how far we can see. Even at the speed of light, the ultimate cosmic speed, there's a fundamental limit to how far back we can see. The farther away we look, the farther back in time we're able to see. Here's what we see as we approach the edge of the universe. Today, we see the universe as it exists 13.8 billion years after the Big Bang. Most of the galaxies we see are clustered together in galactic groups, like the Local Group, and rich clusters, like the Virgo cluster, separated by enormous regions of mostly empty space, known as cosmic voids. The galaxies within these groups are mixed of spirals and ellipticals, where typical Milky Way-like galaxies form an average of one new Sun-like star per year. The majority of normal matter in the universe is made of hydrogen and helium, but about 1 to 2% of normal matter is made of heavier periodic table elements, allowing the formation of rocky planets like Earth and complex, even organic chemistry. While there are diverse kinds, some galaxies are actively producing stars, some have active black holes, and some haven't produced any stars for billions of years. The galaxies we view in space, on our TV screen, our laptop, and our PC, are large, evolved, and clumped together. Since there has not been a concrete resolution to the identification of the edge of the universe of space, could there be a possibility that this has a resultant effect of the expansion of the universe? In other words, does the universe expand? Well, yes. In the 1920s, astronomer Edwin Hubble discovered the universe was not static. Rather, it was expanding, a discovery that revealed the universe was apparently born in a Big Bang. Therefore, it was long thought that the gravity of matter in the universe was certain to slow the expansion of the universe. Then, in 1998, the Hubble Space Telescope's observations of very distant supernova revealed that a long time ago, the universe was expanding more slowly than it is today. The universe's expansion continues today due to dark energy, a hypothetical form of energy that exerts a negative repulsive pressure acting as the inverse of gravity and accounting for 72% of the universe's total mass energy density. The expansion of the universe means the distance between galaxies is growing. Although Einstein's theory could easily describe a universe with no edge, or one that curves back on itself like the surface of a football, later confirmation would be to observe the same galaxies on opposite sides of the universe when you look far enough away with your telescope. Think of the expanding universe as a raisin bread model. Assume you have a ball of dough with raisins all over it. Now imagine that dough leavens, expanding in all directions. You could also choose to further your imagination by seeing this happen in a zero-gravity environment, like on the International Space Station. Now if you place your finger down on one raisin, what do you see the other raisins doing? The closest raisins to you will appear to move slowly away from you as the dough between them expands. Therefore, raisins that are farther away will appear to be moving away faster, as there's more dough between them and you than the closer raisins. Raisins in the distance will appear to be moving faster. Now, in our illustration here, the raisins are the galaxies, or bound groups or clusters of galaxies, and the dough is like the expanding universe. But in this case, the dough represents the fabric of space that cannot be viewed or directly observed, doesn't actually get less dense as the universe expands, and simply provides a stage for the raisins or galaxies to inhabit. How quickly does the universe expand that scientists are unable to reach the universe's end in space? According to the Astrophysical Journal, researchers using the Veteran Space Telescope have estimated that the expansion rate of the universe is 73 kilometers per second per megaspark, plus or minus 1. That means that if you look at an object that is 1 million parsecs, or 3.26 million light years away, the expansion of the universe would make it look as it appears it's moving away from you at 73 kilometers per second, which is over 163,000 miles per hour. The latest data is now understood to have a probability of over 1%. The problem is that a completely different estimate of the speed of the universe's expansion, just 400,000 years after the Big Bang, estimates the expansion to be 67.5 kilometers per second per megaspark, plus or minus 0.5. The tension between the two measurements has just grown and grown in the last few years. Reasons why these two numbers don't match are not known, and there is only a 1 in a million chance that the tension between them is a fluke. Therefore, the insinuation that there might be something else out there has yet to be concluded. Researchers have tried to measure the universe's current rate of expansion in two primary ways: by measuring distances to nearby stars and by mapping a faint glow dating back to the infant universe. These dual approaches provide a way to test our understanding of the universe across the more 13 billion years of cosmic history. But these two methods reduce the universe's current expansion rate by about 8%. That difference might not sound like much, but if its conclusion is real, it means the universe is now expanding faster than even dark energy can show, meaning some breakdown in our accounting of the cosmos. To imply that the universe is accelerating actually means that if you watch an object as the universe expands, it will not only continue to increase in distance from you, getting farther and farther away, but the light that you get from this object will continually show an ever-increasing redshift, which makes it appear as though it's rising faster away from you. In actual fact, though, the redshift is a result of the expansion of space, not the galaxy speeding away from you faster and faster. If we were to actually measure the expansion rate over time, it is still decreasing and will eventually asymptote to a finite positive and non-zero value. That's what it means to live in dark energy dominant universe. Over the next decade, astronomers will expand their approaches to studying the expansion of the universe, and new and upcoming observatories will hopefully provide enough data to make us understand what's going on with the universe that we are yet to comprehend. This will most likely prompt us to ask, how would the universe end? It is expected for anything with a beginning to have an end. Therefore, since there is an unresolved fact to prove the exact edge of the universe, an end should be known. How will the universe end? Until rather recently, astronomers believed the cosmos would repeatedly expand and break down in an infinite cycle of cosmic death and rebirth. But the most valid proof points to a distant Armageddon, filled with more existential dread than havoc than the holy book of Revelation. Trillions of years in the future, long after Earth is destroyed, the universe will drift apart until galaxies and stars formations cease. Slowly, stars will fizzle out, turn the night skies black. All suspended matter will be gobbled up by black holes until there's nothing left. Finally, the last traces of heat will disappear. Instead of meeting its end through fire and brimstone, the cosmos will likely succumb to heat death. Astronomers call it the Big Freeze. It really was an amazing ride in space. Understanding the universe, its beginning, and its end. I'm sure you would love to see more amazing facts about the wonders of space that would sweep you off your feet. For more revealing videos, subscribe to our channel. Also, click the notification bell below and get notified whenever we drop a new video. And just before we go, I'm sure you found this video really insightful. Do well to click the like button. We would also love to hear what you think about this video by dropping a comment in the section below. See you in our next video.